Good morning, everybody. Today we are discussing the topic radius ratio and coordination number. We know coordination number of particular sphere depends upon the number of spheres touching to that sphere. That means how many spheres, how many atoms coming in contact with the sphere. That will be the coordination number of the sphere. Suppose this is the small sphere surrounded by a sphere. So, coordination number of this central sphere is 1, 2, 3, 4. That is 4. So, coordination number means number of sphere coming in touch with the particular sphere. That will be the coordination number of the central sphere. Every crystal has made of different ions, cations and ions. Generally, cations are considered as a central spheres. Generally, we are considering cation is a smaller size compared to anion. So, in case of ionic crystal, it is present at the points through which the anions are touching to the spheres. So, in case of crystals, the structure of crystal also determined by knowing the size of cation and anions. If size of cation will be small, then number of anions touching to the cation will be less. If you take a small sphere, then same number of anions will be contact. That is number of, if you compare the first case and second case, the second case will be less number of spheres touching to the central sphere. So, the size of cation also determine the coordination number. So, size of cation anion can be determined from the crystal from a radius ratio. A radius ratio, it has significance in crystal to determine the structure of the crystal. So, what is the radius ratio? Let us discuss this thing. A radius ratio generally expressed in terms of R plus and R minus. That means it is the ratio of size of cation to the size of anion. Size of cation generally it is the central sphere present or available at the points. Then R minus are the surrounding spheres. The radius ratio, it is already experimentally calculated that there is a relation between a radius ratio and coordination number. What is that? Radius ratio, coordination number and shape. Already I have told you, the shape of the crystal, the structure of crystal also depends upon the radius ratio. That is also depends upon coordination number. If radius ratio is less than 0.155, if radius ratio is less than 0.155, the coordinates number will be maximum 2. The set is linear set. Linear set. It will be linear, either horizontal or vertical. If it lies between 0.155 to 0.225, it will be, coordination number will be 3 and the shape is triangular. Triangular shape. If it is 0.225 to 0.414, that will be, coordinate number will be 4 and shape will be tetragonal or tetrahedral. Tetrahedral or tetragonal. 0.414 to 0.732, that is, it will be 6 and it is octahedral. Octahedral type. If it is 0.7321, it will be 8. That is shape is cubic pattern. Cubic arrangement. It will be cubic arrangement. If exactly 1, this is the hash value, range, this is the hash value within this. But if it is exactly 1, the coordinate number will be taken as 12. That is your CCP or is SCP. Cubic closed packing or hexagonal closed packing structure. In 3D concept, that is in 3D. So these are the relation between the radius ratio and coordinate number and shape. Just you observe the table. It is observed increasing the radius ratio, also increasing coordinate number. You see the table. Radius ratio is increasing and coordinate number also increasing, and also shape also changing. So there is a relation between a radius ratio, coordinate number and shape of the crystal. A radius ratio can be determined by knowing the size of cation or anion. Let us discuss some problems. The first problem, the crystal is calcium oxide. The size of calcium ion is 94 picometer and size of oxide ion is 146 picometer. Question is, predict the structure of calcium oxide. Here, only size of cation and anion are given. We have to determine its structure. But structure can be determined if you know the radius ratio. Already I have told you, the radius ratio has significance that we can know the structure of the crystals. So as the cation size and anion size given, let us calculate the radius ratio of this calcium oxide. So R plus is equal to how much? 94 picometer, and R minus, that is oxide ion, is 146 picometer. So determine the radius ratio. The radius ratio is equal to R plus by R minus, which is equal to 94 by 146. The value will be this value will be 0.644, and the radius ratio has no units because size of cation, size of anion means this, it will be unitless. So 0.644. If you compare the table that already discussed, 0.644, which part is coming? It is coming between, you see the table, that 0.4142 to 0.732. Within this range it is coming, that 0.644. Already know its condensation number is 6. So shape will be octahedral. So as it is 0.644 and its condensation number will be 6 and shape will be octahedral. Octahedral arrangement. The calcium oxide, the shape is octahedral arrangement. Similarly, the second problem, what is this? Every crystal has NaCl type, that is FCC type, face-centered cubic type. Size of A plus 120 picometer. Calculate the maximum possible value of size of anion. Here, already given FCC, AB has NaCl type, that is FCC type, and the size of A plus is 120, and we will calculate size of B minus. But one thing here, as the FCC is just like your octahedral pattern. FCC means it is also type of octahedral pattern. That means your radius ratio here, radius ratio, that is R plus by R minus. Here R plus means yes, A plus, that is A plus by B minus, is equal to size of A plus is 120 picometer and the size of B minus is asked. But here already hints given, already data given, FCC type. FCC type means the coordination number will be 6 and the range is 0.414 to 0.732. This is the maximum coordination number. This is the maximum value, this is the minimum value. minimum coordination number means as coordination number is cation to anion ratio, just you see, if anion size increases, look at the here the relation. If anion size increases, radius ratio decreases. If anion size increases, radius ratio decreases. But here, you see the question, maximum value. Which value? Anion size should be maximum. Maximum anion size means minimum radius ratio. That is, we have to take 0.414. So that will be 0.414. So you put this value. Now B minus is equal to 0.414. B minus equal to 120 picometer upon 0.414, which is equal to, the value will be, maximum value will be 290 picometer. It will be 290 picometer. We calculate the result will be 290 picometer. So 290 is the maximum size of anion for this type of crystal, where the cation size is 120 picometer and the shape of the crystal is FCC type, phase centered cubic type. So this problem indicates both size of cations, anions, coordination number, radius ratio are responsible for determining the structure of the crystal. Now, I will give some idea regarding some important reference crystal. We have to know this regarding this crystals. What are the arrangement? What is the coordination number of this reference crystal? These are called some reference crystal, important crystal, so that we can compare with other crystals by knowing these reference crystals. What are the reference crystals? Reference crystal first is your rock salt type. Rock salt type means it is called NaCl type. In NaCl type, it is FCC pattern. It is FCC pattern, FCC type. Means phase centered cubic closed stacking arrangement, FCC type, and here Na plus in the crystal, Na plus occupies in the octahedral parts at octahedral parts. Na plus occupies at octahedral parts and Cl minus occupies at the CCP arrangement. CCP arrangement. CCP arrangement means at the corner, and but Na plus occupied at the parts. Only at the parts Na plus occupied, and other position occupied by the corners occupied by the Cl minus. And coordination number of this NaCl is 6:6. Similarly, second crystal is cesium chloride. These are the reference crystals. We have to remember. Cesium chloride, it is simple cubic arrangement. Simple cubic arrangement is arrangement simple cubic type, and your cesium plus occupies at the body center. and Cl minus occupies at the CCP arrangement. At CCP arrangement. And here coordination number is for cesium plus and Cl minus is 8:8. You have to remember this relation. Coordination number of cation and anion for this type of reference crystal. Next one is zinc blende type. Zinc blende. Zinc blende means ZNS. ZNS. In ZNS, it is FCC pattern. FCC pattern arrangement and Zn2 plus are the tetrahedral hertz. At the tetrahedral hertz means Zn2 plus remains at the tetrahedral hertz. You have to remember this thing. That's why we are discussing some particular, so many crystals, so many ionic crystals, but we cannot remember all what type of crystal, whether it is zinc blende type. If in the question it is given, some hints given, it is just like in the problem already discussed. It is NaCl type, already written. It is NaCl type. Similarly, zinc blende, the Zn2 plus remains at the tetrahedral hertz and sulfide ion at the FCC pattern. At FCC pattern. FCC arrangement. FCC arrangement means your corners, other positions, but hertz only occupied by Zn2 plus. And here coordination number is generally in the question general asking, the coordination number of the reference crystal is 4:4. You have to remember. Then fourth one type is fluoride type, fluoride structure. Fluoride type structure, that is calcium fluoride. Fluoride, not fluoride, is fluoride type structure. Here, calcium ion occupies FCC arrangement and F minus are the tetrahedral hertz. You have to remember at which hertz which ion occupies. F minus are the tetrahedral hertz. And the coordination number for this type of crystal is that is called Fb2 type. This is called also Fb2. This cation is 1 and anion is 2. Fb2 type. Coordination number will be 8:4. If you see, 1 calcium combined with 2 fluoride, but in the structure is not like this. Is the simplest formula. Actually, in the formula, in the arrangement, in the cubic arrangement, it is 8:4. Another is anti-fluoride. Anti-fluoride. Anti-fluoride type is your sodium oxide. Just opposite. Just you see, fluoride. 1 calcium, 2 fluoride ion. Here 2 sodium ion, 1 oxide ion. Just opposite. It is what type? A2B type. A2B type. Just opposite. Here in the previous one, calcium ion occupies FCC arrangement. Here oxide ion FCCR. Then your sodium ion at the tetrahedral hertz. Just opposite. And coordination number is also just opposite of chloride, that is 4:8. 4:8. So these are some reference crystal. Their cation anion position and coordination number and the type of crystal we have to remember, so that we can solve different types of problems. Thank you all.